Welcome back to the channel and another video. In this video, we are going to be looking at back-titration. So you would have been familiar with titration already, where you may want to find the concentration of an acid or a base. So we would have just added the solution directly from the burette into the conical flask, right? But for a back-titration, we cannot just go straight ahead and carry out the titration for more than one reason. So if one of the substances is volatile, then we carry out the reaction first, then follow it up with a titration. Or if one of the substance has an extremely low solubility, we will have to carry out a reaction first. So with a back titration is not a direct titration, right? So we carry out a reaction first, then a titration. And we'll look at why we need to do the reaction first. So the reaction followed by a titration, right? So typically in the back titration, right? So for example, in this question, we have a sample of ammonia, right? An ammonia solution. I want to know the concentration of ammonia present. But ammonia is a volatile substance, so we want to do a direct titration. So what we would do, react the ammonia. So in this case, we get the ammonia. So from the question, we have our ammonia solution into the conical flask, right? And we add hydrochloric acid, right? So ammonia is the base, hydrochloric acid is the acid, right? So this is not, we are not doing any titration at this point. We are just carrying out a reaction here. But the first part of this, whichever substance we are interested in, so for example, we're interested in finding out the concentration of ammonia. So whatever volume of ammonia we are reacting with the acid, we need to ensure that we have more acid than ammonia. So we always add the acid in excess, right? It don't have to be an acid, so whatever substance you're interested in finding out the mass for or concentration, that must be the limiting reagent. It must be in short supply. So we are reacting ammonia and hydrochloric acid. So the hydrochloric acid must be in excess. It must be more than the ammonia. So that's the first part of our back titration. We will do a reaction. And in that reaction, your substance of interest must be in shorter supply when you compare it to the other substance you are reacting it with. Because we need to ensure that all of it reacts, right? Then now, because in this case the hydrochloric acid is in excess, we will not know exactly how much of the hydrochloric acid reacts with the ammonia. That is where the titration comes in, right? So the reaction is between ammonia and HCl. But remember, we're trying to figure out the concentration of ammonia. Now, we know the volume and concentration of the HCl. So we can use that to calculate the mole of HCl and then use mole ratio from a balance equation to get the moles of ammonia. But you have to remember that the hydrochloric acid is in excess. Not all of it will react with the ammonia. Some of it will be left unreacted. So we have to find out how much of the HCl was left over, right? Did not react with the ammonia. And that happens in every back titration. The substance that you add in excess, you will not know exactly how much of it reacted with the other substance. So that is why we have to do now the titration, right? So whatever is left over will be used in the titration. So the titration will tell us what was left over. We know how much we start out with, and the titration tells us how much was left over. So therefore, if we know the total that we started with and what was left over, we just simply subtract and we know how much was used in the reaction. And that's what's happened for every back titration. So let's look at this question. So it says a student was asked to determine the ammonia concentration. Remember, square brackets means concentration. So a student was asked to determine the ammonia concentration, again, which is a volatile substance, so that is why we do back titration. In a commercially available cloudy ammonia solution used for cleaning, the student pipetted 25 ml of the ammonia solution into a conical flask. 50 ml of 0.1 moles per dm cube. Capital M there, it means moles per dm cube. So 50 ml of 0.1 moles per dm cube of hydrochloric acid was immediately added. So that's the reaction, ammonia and HCl. The excess, right? Right here now, the excess HCl, this here means what was left over. So any unreacted HCl that was left over, we use it now in the titration. So we titrate it with a base. So we titrate it here with 0.05 moles per dm cube sodium carbonate. And whatever HCl was present, it required 21.5 mils of the sodium carbonate solution. Now there is more than one way to solve the question, or there's more than one order in which to work it out. So the way I'm going to do it, right, we are going to separate the questions into the reaction portion and the titration. So two things happened in the question. A reaction occurred as well as a titration. So we need to pick out all of the information. So first, we know that we have 25 mils of the ammonia solution, right? In the reaction, we used 50 mils of 0.1 moles per dm cube HCl. Now, after that reaction was completed, the unreacted HCl, we titrate it with sodium carbonate, right, of that concentration, and the volume of sodium carbonate was 21.5 mil. So this portion of the question, right, all of over here, come down. This is the titration portion. Up here is for the reaction. So to work it out now, I'm going to separate the reaction portion from the titration. So you can pause the video and write off the question, because I'm going to erase it now and work it. Alright, so let us separate them. So over here we will have the reaction, and over this side we are going to work out whatever as it relates to the titration. So in the reaction, we know we used ammonia, right? And for that we have the volume, which is 25 mil. and our objective is to find the concentration, which we don't know, right? We know that for the reaction, we use hydrochloric acid, and for that, the volume 50 ml, and we have the concentration, which was 0.1 moles per dm cube. And for the titration, we know we use sodium carbonate, the volume was 21.5 mil, and the concentration was 0.05. Good? So remember now, and in this one, in the reaction, we have the total HCl, but in the titration, we use the unreacted HCl. Right? So that's how you can set out the question. So it doesn't matter how complicated the question might have been phrased, it is always a reaction followed by a titration. So in the reaction, it was ammonia and hydrochloric acid. So we have the volume and concentration for hydrochloric acid. Whichever one you have the volume and concentration for, work out the moles. Alright? So we know that mole is equal to concentration times volume. Concentration 0.1 moles per dm cube. The volume in dm cube, milliliter is the same as cm cube, and we know that 1 dm cube is 1,000 cm cube. Is that, yeah, 1 dm cube is 1,000 cm cube, so this would be 0.05 dm cube. So the number of moles of HCl is 0.005 moles. Now this is the total mole. This is the total moles of HCl. So whatever is used in the reaction, it is the total amount used, right? So that's the mole of HCl. Once you do that, we are going to write the equation for the reaction. So the equation for the reaction is, alright, so we have the ammonia solution reacting with HCl, and we're going to get ammonium chloride. Once you write the equation, we're interested in finding the moles of ammonia, and we're going to use the mole of HCl. So we need to use mole ratio. So the mole ratio is 1 to 1. Now remember, this mole of HCl is the total. So we cannot use this mole of HCl to find this mole of ammonia. So once you reach this part, you are going to pause here and move on to the titration. So when we start with the reaction, we calculate the total moles, write our equation, write the mole ratio, and pause for that part. Now let's go over to the titration aspect of the experiment. Alright. So in the titration now, we know we use, alright, let me just bring it over, get some more space. Alright, so now we get to the titration. We are going to work out the moles of sodium carbonate. So we know that mole again is equal to concentration times volume. Concentration is 0.05 moles per dm cube multiplied by the volume in dm cube, which would be 0.021 5 dm cubed. And the answer you should get at that point is 1.08 times 10 to the minus 3 moles. Alright, so that's the amount of moles of sodium carbonate that was used in the titration. So that is the amount of moles that was used to neutralize the excess hydrochloric acid. So at that point, let's go ahead now and write our balance equation for the titration. So it's between sodium carbonate and hydrochloric acid. And we know when carbonates and acid react, we're going to get salt, carbon dioxide, and water. Alright? So equation is balanced, not as yet. Right. So remember now, we know the moles for the sodium carbonate, but we don't know the moles of HCl. Remember, it's the unreacted HCl that was used in the titration. So we're going to use the mole ratio between sodium carbonate and hydrochloric acid to get the moles of the unreacted HCl. So the mole ratio is 1 to 2 between sodium carbonate and HCl. So to get the mole of HCl, it's 1 sodium carbonate to 2 HCl. So it would be, so the unreacted HCl is equal to 2 times 1.08 times 10 to the minus 3. And we should get 2.16 times 10 to the minus 3 moles. Alright? So we know the total moles of HCl that was used in the reaction, 0.005. Out of these 0.005 moles, this amount did not react with the ammonia. So if this is the total and this amount did not react, then the amount of moles that actually reacted would be 0.005, which is the total minus the unreacted. So to get the reacted mole of HCl, it would be the total, which is 0.005 minus the excess 2.16 times 10 to the minus 3, and you will end up with 2.84 times 10 to the minus 3 moles. Alright? So that's how we get the amount of moles of HCl that react with the ammonia. Now remember, all along, all we wanted to find out is the amount of moles of HCl that reacted with the ammonia. So we can use the mole ratio between ammonia and HCl to get the moles of ammonia. So now we know that this amount of moles of HCl reacted with ammonia. And since the mole ratio between ammonia and HCl is 1 to 1, then the mole of ammonia is the same. So once we get the amount of HCl that reacted, we are finished with the titration. So the titration was to allow us to get the moles of HCl that was unreacted, and therefore the amount that actually reacted. So we come back now to our reaction portion to complete the calculation. So the mole ratio is 1 to 1. So the mole of ammonia is equal to 2.84 times 10 to the minus 3 moles. And so if we want concentration, we know that concentration is mole divided by volume. So it's 2.84 times 10 to the minus 3 moles divided by the volume of ammonia in dm cube 0.025 dm cube, and you should end up with 0.114 moles per dm cube. Right? And that's how you do a back-titration. So in every back-titration, you will carry out a reaction. And remember, you have to do a reaction because the whole point of doing a back-titration is for some reason you cannot go ahead and do a direct titration. Right? So every back-titration question is going to give you a reaction that occurs. One of the reagent, whichever one you are not trying to find the concentration or the percentage by mass for, that reagent is going to be in short supply and you add the other reagent in excess, right? So you carry out a titration with what is left over. So again, separate the question, a reaction and titration. For the reaction, calculate the moles of the substance that you have the concentration and the volume for. Once you get the moles, write your balance equation, write the mole ratio. You stop there. Come over to the titration. You would have gotten the volume and concentration for a substance used in the titration, whether it's acid or base. Work out the moles for it. Write the equation for the titration. Again, use the mole ratio to get the moles of what you want. In this case, we wanted the mole of HCl. We use the mole ratio and we get the amount of moles of unreacted HCl. Alright. So this was the mole of sodium carbonate. Once we get the mole of sodium carbonate, we write our balance equation, use mole ratio to get the unreacted moles of HCl. So in terms of a step, you calculate total moles. That's step 1. Write the equation for the reaction as well as the mole ratio. Then you pause there, come over to the titration, calculate the moles of whether it's the acid or base, whichever you have the concentration for. Then you're going to write the equation for the titration and use mole ratio to find the moles of the unreacted substance. So that's 5. Once you get the unreacted number of moles, you're going to subtract it from the total to get the reacted amount. Alright, so 6, you get the amount of substance that actually reacted. And step 6 ends the titration. Come back to step 7. Come back to the reaction where we have step 7. So the reaction is step 1, step 2, then step 7. Alright, step 7, you get the mole of the substance using the balance equation you had already written. And once you have the mole now, you finish with step 8, which is to get the concentration of the substance. Alright, so our back titration of 8 steps. 4 for the reaction, and 4 for the titration. Alright, so I'm going to end this video here and work 2 more questions in the next video in part 2. So if you have any questions, you can leave it in the comment sections. Right, so this is the procedure for working out about titration. Question: